For our very last section of this class, we're going to look at a couple different videos here revolving around the same function. So we're going to start off with a function. Here I have f of xy is equal to x squared plus xy plus y squared minus 7x plus 4y plus 9. And to start off, I want to just find the critical points. We're not going to do anything with them quite yet. That'll be in the next video. For now, I just want to go ahead and find those critical points. So critical points occur where the partial derivative with respect to x is equal to 0 and the partial derivative with respect to y are equal to 0. So it seems like that is a good place to start. I'm going to find the partial derivative with respect to x, and then we'll find the partial derivative with respect to y, set them equal to 0, solve for our x and y values. So starting off with the partial derivative with respect to x, derivative of x squared would be 2x, derivative of xy, remember y is a constant, so the derivative of x would be 1 times y, giving me just plus y for that middle term. Y squared, derivative of y squared with respect to x, y is a constant, so its derivative is 0. Derivative of negative 7x will be minus 7. Derivative of 4y is a constant with respect to x, so its derivative is 0. And 9, of course, is a constant, so its derivative is 0. So I want to take this partial derivative with respect to x that I found, set it equal to 0, and solve. Now, the only issue I'm going to run into, I've chosen a slightly more involved problem for finding the critical points. I am going to run into a slight problem here because I have two different variables. I have x and y. If, for example, the partial derivative with respect to x had only x left over, then sure, yeah, we know how to solve an equation with one variable, but for two, well, we're going to need another equation, which is where the partial derivative with respect to y comes in. So let's take a look at that. So the partial derivative with respect to y, x squared is a constant with respect to y, so its derivative is 0. Derivative of xy, derivative of y would be 1 times x is just x. Derivative of, let's see, y squared, that's going to be plus 2y. Derivative of negative 7x, that's a constant with respect to y, so its derivative is 0. Derivative of 4y is going to be plus 4, and of course 9 is a constant, so its derivative is 0. So here are my two partial derivatives, and whoops, I want to set the partial with respect to y equal to 0 as well. So essentially what I have is a system of equations because I want an x and a y value that satisfy this equation and this equation. So I'm going to go ahead and solve this using substitution. I think that's probably the easiest way to go about this. I'm going to pick either one of these partial derivatives, doesn't matter which, and either one of my variables within that partial derivative. So just for the sake of ease, I'm going to go ahead and choose this partial derivative over here, and I'm just going to choose the equation, or excuse me, the variable that's easier to solve for, which I think y is going to be easier to solve for. So I'm going to go ahead and subtract 2x from both sides and add 7 to both sides. That should give me y is equal to positive 7 minus 2x. So I have this relationship between y and x, and I can now take that value for y that I've solved, and I'm going to go ahead and plug it into this other equation over here, my partial derivative with respect to y. So over here, I have x plus 2 times, I'm going to go ahead and plug in now that part in blue, this 7 minus 2x, and then back to black right here, plus 4 is equal to 0. And what we should end up with is, hey, look at this. This equation is only in terms of x, and well, now it's become a whole heck of a lot more manageable. So I'll go ahead and distribute the 2 here. This becomes x plus 2 times 7 is 14, minus 4x plus 4 is equal to 0. And then we'll combine our like terms, solve for our variables. So x minus 4x, that should be minus 3x. And 14 plus 4, of course, gives me 18. Oops, gives me plus 18 is equal to 0. Let's go ahead and add 3x to both sides. I don't want to have to deal with negatives. So 18 is equal to 3x, and then if we divide both sides by 3, I end up with x equals 6. So there is my x value. Once we found that x value, we should be able to take that x value and plug it into, at this point, either one of our equations. But if I look over here at the partial derivative with respect to x, we've already got y solved for. This is going to be a nice, simple equation to work with. So y is equal to 7 minus 2 times x. We just said x is equal to 6. So y must be equal to 7 minus 12, giving me negative 5. So I have at this point my x value and my y value. I've got x is equal to 6 and y is equal to negative 5. So to finish this problem up, my critical numbers for these types of problems will always be an ordered pair, right? So we're going to have x comma y. So our x value we said was 6 and our y value is negative 5. Here is our critical point. It is certainly possible for you to end up with more than one critical point. I wouldn't expect the homework problems to have more than at most 2. Most will probably only have 1 though. In the next video, we're going to go ahead and work with this critical point and classify the behavior to talk about whether we have a local minimum, a local maximum, or a saddle point.